All right. Got Algebra 2, OAS A201, A2A18. The student will solve systems of linear equations using the substitution method, lecture 322 and 323. Systems of linear equations, when we have a system, that just means we have more than one equation in more than one variable. So that's what we're going to be dealing with. We'll have more than one equation with more than one variable. And what we'll be doing is just two equations with two variables to start. Okay, so here we go. Here are the steps we're going to follow. I won't bother reading them to you. You can stop this at any moment and read these. But by the time we get to step 6, we'll be looking at the answer, our solution to the system. Okay. Here are two situations we may run into. A system has no solutions or a system has infinitely many solutions. We will not run into that today, but we will run into it 2 days from now in our next lecture. So we're not going to pay any attention to this for now. What I'm going to do is solve using substitution. That is these 6 steps. And that will give me an x and y value that will make both of these equations true. Okay? So here we go. I'm going to go step 1 and see what it says to do. Step 1 says solve either equation for either variable. So what I want to do is look for the easiest variable to isolate and do that. Always choose the easiest, the one that involves the least amount of work, is how I personally look at it. So I say, well, I can solve for x, or I can solve this one for y, or I can solve this one. Hey, this one is already solved for y. When we say solve for a variable, that means get the variable on one side of the equal sign all by itself and everything that it's equal to on the other side. So this one has already got step 1 taken care of. This one has y solved. So what I'm going to do is go to step 2. Step 2 says substitute into the other equation. So what I'm going to do is, this is already solved for y. I'm going to take this and plug it into the other equation for y. Y equals this. So I'm plugging this in right here for y. Then I'll have an equation in just one variable. I have negative 4x plus 4, instead of y, I'm writing this because this is what y is equal to. In parentheses, negative 2x plus 7, kind of a weird looking parenthesis, is equal to negative 20. And we're going to solve this and try not to make any arithmetic mistakes. If you see me make any arithmetic mistakes, normally I'd say shout out, but since I'm doing this on the video, I will try not to make any mistakes. If I make some, hopefully I'll catch them. So here we go. I'm going to open these parentheses first and then combine like terms on the left side. Negative 4x comes down, minus 8x, plus 28. I'm just distributing this using the distributive property of multiplication with respect to addition. Plus 28 is equal to negative 20. I'm going to combine like terms. That will be these terms right here. That will give me, they're the same sign, so I'm going to add them together, 12x, and keep the sign. Plus 28 is equal to negative 20. Now I'm going to subtract 28 from both sides and then divide by negative 12, and I'll know what my x value is. So I'm subtracting 28 from both sides. This gives me negative 12x is equal to negative 48. These are the same sign, so I'm going to add them together and keep the sign. Now I want to divide both sides by negative 12. Now I've got x is equal to 4. Negative 48 divided by negative 12 is positive 4. All right, so I found one of my variables. I found that x is 4 in this system. I just substituted into the other equation and solved for the single variable. That's step 3. Step 4, substitute what we just found into any equation you want. I always look for the simplest equation and then solve for that variable. And once we get done, we'll have an x value and a y value, and we just write them as an ordered pair. So I'm going to take what I just found, x equals 4, and plug it into any equation that I can see. I'm going to plug it into the easiest one, and the easiest one I see is plugging this x value right here. And we can do that in our head. If I plug in a 4 right here, this will be y is equal to negative 2 times 4, which is negative 8, plus 7. Negative 8 plus 7 is negative 1. So if I haven't made any mistakes, if x is 4, y has to equal negative 1. And my ordered pair will be, we write them in alphabetical order. The variables don't have to be x and y, but if they're, for instance, they were m and n, we would put them in alphabetical order. It's just standard. 4, negative 1. What this means is that 4 and negative 1, x and y values respectively, will make this equation true if I plug them in here and here, and this equation true. Graphically, what that means is if I graph this, and then I graph this, these two graphs will intersect each other at the point 4, negative 1. That's what the solution of a system in this case, like this, means. That's what solutions mean. We're dealing with linear here. Alrighty. So now I want to check and see if I got it right. Where's my answers? 4, negative 1. Yay. Okay, so I just followed those steps. I'm going to do another one. Here I go, I look at this. On step 1 says, solve either equation for either variable. And I look up here and see I'm looking for the easiest one. I could solve this for x or solve this for y, or this one's solved for y again already. So I don't have to do step 1. Step 1's already done. So I'm going to go to step 2, which says plug this in to the other equation. Instead of y, I'm going to plug in 8x plus 11 as a quantity. So this will be 8x minus 8x plus 11 is equal to 14. This will give me 8x I messed up. I left out my 6 right here. Sorry about that. Don't get in a hurry. I just got in a hurry and I realized this one was not going to have a solution. And I just told you that they would have solutions, so I was looking to see where my mistake was. And as I was looking, I noticed it. So I apologize for that. I'm going to take this and plug it in right here. I forgot my negative 6. So here we go. 8x minus 6 times, instead of y, I'm plugging 8x plus 11 is equal to 14. Now I'm at the step 3 that says solve this for the single variable. So I'm going to distribute this negative 6, combine like terms, and then isolate my variable. I'm taking this negative 6 and distributing it. 8x minus 48x minus 66, I'm multiplying, whoops. Is equal to 14. Give myself a little bit of room here. I'll combine these like terms. 8x minus 48x is negative 40x minus 66 is equal to 14. I'm going to add 66 to both sides and then divide by negative 40. I'm isolating that x. Negative 40x is equal to, what is that, 80? Then I divide both sides by negative 40. And x is equal to, what is that, negative 2? All right, so I found x is negative 2. Now I'm going to look for the easiest place to plug this in, and I look up here, and I could plug it in right here and then solve for y. Or I could plug it in right here. To me, this is much easier because y is already isolated. That's the one I'm going to plug it into. So I'm going to take this x value and plug it into x right here. You'll get the same answer no matter where you plug it. You plug it in here, you'll get the exact same answer, but this is just a little easier. So we've got y is equal to, let me scroll a little bit. Okay. We've got y is equal to 8. Instead of x, I'm going to put a negative 2 plus 11 and do this arithmetic. This is negative 16 plus 11, and that would be negative 16 plus 11 is what? Negative 5. And then I would write my answer as an ordered pair, which would be negative 2, negative 5. Putting them in alphabetical order. There's our solution. This ordered pair will make both of these equations true. Put an x here and y here, x here and y here. And if we graph them both, they'll intersect at that point. Negative 2, negative 5, if I haven't made a mistake, or another mistake I should say. Negative 2, negative 5, yay. Okay? So I'm just following these steps. If you're wondering what I'm doing, you can back your lecture up and take a look at it. Here we go. Step 1 says solve either variable for either equation for either variable. Now look at this, and I say this one would be real easy to solve for x. I could just subtract 8y. And this one I would have to solve for x, I'd have to subtract 2y and then divide by 4. So I'm going to do the easiest thing. I'm going to subtract 8y from both sides and isolate that. Step 1 says solve either equation for either variable, and the easiest one to solve for is x by subtracting 8y from both sides. So I'm going to say x is equal to negative 8y plus 10. I'll go ahead and show that little step I did. I took this equation and, well, I'll just do it right here. I said negative 8y, oops. I subtracted 8y here, and I subtracted 8y here. So I got, on the left side of the equation, x plus 0 is equal to negative 8y plus 10. You could have called it 10 minus 8y if you wanted to. I just put the variable first. Okay, so there I've isolated it. Now I'm going to plug it into any equation I want. I'm going to plug it in for the x value, into the other equation, I'm sorry. Solve for either equation, substitute it into the other equation. So I have to take this and substitute it into the other equation. So I'm plugging this in for x right here. This will be 4 times negative 8y plus 10 plus 2y. This is just a big weird looking x now. The reason we're doing this is now we just have an equation in one variable. I'll open my parentheses and solve it for y. This is negative 32y plus 40 plus 2y just comes down is equal to negative 20. I'm going to combine my like terms. Those are different signs, so I'm going to subtract and keep the sign of the one with the greater absolute value. And now I've got a pre-algebra problem. I'm going to subtract 40 from both sides and then divide by negative 30. This will give me negative 30y is equal to negative 60. And therefore, when I divide both sides by negative 30, y will equal 2. 60 divided by 30 is 2. Negative divided by negative is positive. Now I'm going to plug this into the easiest equation I can find where I can plug in a y. And that's this place right here. I solved it for x. That's the easiest place I can plug it because I just do this arithmetic and I'll know my corresponding y value. So I'm going to take this. I can plug it in anywhere, but that's the easiest place. And we can do that in our heads. This will be x equals negative 8 times 2 is negative 16, plus 10 is negative 6. So if y equals 2, x equals negative 6, if I haven't made a mistake. And then we write our answer as an ordered pair. Negative 6, x comes first, 2. Alrighty. So that is substitution. I'll do one more here in just a second. Let me make sure I got that right. It's always embarrassing when I miss. Negative 6, 2, yay! Okay, let's do one more. And again, if you wonder, what in the world is he doing? I'm doing this. I'm just running through these steps. You can go back in your lecture and stop it and read through these. I'm telling you what I'm doing as I'm going, and this is what I'm saying. Okay, so here we go. Do another one. Last one. Step 1 is solve either equation for either variable. So I'm going to solve this equation for y, because to me that's the easiest one to solve for. If I just add x to both sides, y is by itself. By solving means getting one of the variables by itself. So I'm going to add x to both sides. And I'm going to say y is equal to x minus 2. I like to put my variable first. You don't have to. You could have called this negative 2 plus x, and you get the same thing. Now I take this and I plug it into the other equation. Instead of y, I'm plugging this. That's step 2. Solve either equation for either variable, substitute it into the other equation. Okay? Oh, here. This is the other equation, so this will be negative 8x plus 7 times x minus 2. Make sure you put that in parentheses because it's the whole thing being multiplied by 7 is equal to negative 13. Now I'm just going to open my parentheses, do my combination of like terms, and hopefully I won't make any mistakes. So here we go, negative 8x plus 7x minus 14 is equal to negative 13. Negative 8x plus 7x, combining like terms, that will give me negative 1x. I'll just call it negative x. You could call it negative 1x if you wanted to, it doesn't matter. Minus 14 is equal to negative 13. And now what I'm going to do is I'm going to add 14 to both sides and divide by negative 1. To get x by itself, we undo what's added or subtracted, rewrite our equation, and undo what's multiplied or divided. So I'll add 14 to both sides, then divide by negative 1. Here we go. Adding 14 gives me negative x, or you could call it negative 1x, is equal to 14 minus 13 is 1. Dividing both sides by negative 1 will yield x is equal to 1 divided by negative 1 is negative 1. So the value of x is negative 1. Now I have solved for the single variable. I plug that in to any equation that has two variables. You have to pick an equation that has two variables, plug that value I just found in, and solve for the other variable. I always look for the simplest equation to plug it into, and that's right here. If you look at all the equations we got, this is the simplest one to plug in an x value. So when I plug this in, I'm going to choose to plug it in right there. You'll get the same value no matter where you plug it in, as long as your equation has two variables. Here, there's only one variable, so you don't want to plug it in there. You'll get an identity. So here we go. Plug it in. And we're going to do it in our heads. What the heck? This is negative 1 minus 2. Those are the same sign, so I'll add and keep the sign. Y is negative 3. You plug in a negative 1 right here. Negative 1 minus 2 is negative 3. Y is negative 3. So our ordered pair will be x comes first, y comes second. And this is the point of intersection. If we graph both of the original problems, they'll intersect at the point we just found. And those x and y values are the x and y values that will make both of the original equations true. Now let's see if I got that one right. I hope I did. Negative 1, negative 3, yay! Okay, so that's using substitution. It's all based on these steps. By the time you get to step 6, you'll be looking at an ordered pair that will make both of your equations true. You can do this.